Hello. 1 minute and we start. Okay, welcome everybody to this new session and this new webinar about encapsulator technology. My name is Hernan Dominguez. I'm the Vice President of Sales and Marketing. I came from Argentina. And today we have this training session with Ron Lowery and that he can introduce. When we finish, you can send questions and answer. When we finish, we will have some minutes to make some question and to answer all your questions. And please let us know if you need any information to share with all of you. Please, Ron, if you can introduce yourself and start the meeting.
Yeah, thanks, Hernan. As Hernan said, my name's Ron Lowery. I'm the Eastern Area Manager for Hazard Control Technologies. In addition, as you can see here on the screen, I'm also a NFPA certified, Pro Board certified Instructor 1, Firefighter 1 and 2, and a Fire Chief in Western Pennsylvania. So as Hernan said, if we can just kind of, little housekeeping here, keep our microphones muted until we get to the Q&A section in the end. You can always write questions in the chat. Again, if you'd like to receive a copy of the presentation and a certificate of attendance, please ensure that you put your information in the chat so that we have that and can cross-reference it with the registrations. So just a little bit about hazard control before we get started again. We've been around since 1997, a global company. As you can see from the across the top there, we're pretty much on every continent. We specialize in the control of today's modern hazards. We are the inventors of encapsulator technology that can be used for fire control and vapor mitigation. So, when we talk about encapsulator technology and hazard protection, it is a multi-class encapsulating agent that can handle various classes of fires, be that A, B, D, or, the ever-present lithium-ion batteries that we're currently dealing with can all be handled with one F500 encapsulating agent. The topic that we're going to focus on for today's webinar is strictly around structure fire applications. So the agenda for today's webinar is we're going to look at the various risks that are associated with today's modern structure fires, and then how we can help control and limit those risks and improve the outcomes of those situations with F500 and with encapsulator technology. So when we're talking about these modern hazards, for today's fires, the things we're talking about, synthetic materials, the lightweight construction that we're dealing with, which then leads to, again, rapid fire spread, hotter fires than we've had in the past, which lead to earlier flashovers and an earlier chance of collapse within that structure. So real quick here, this is a video. I know everybody's pretty familiar with the work that UL has done comparing the legacy and the modern furnishings. Well, they just redid that test again here in 2020 with the Fire Safety Research Institute and UL. Again, looking at that side-by-side demonstration of legacy furnishing materials compared to modern day furnishings. And as we go through the video here, there's some things we'll kind of stop the video that I want to point out as we're going through, looking at what we faced previously to what we're facing today. So again, they're using a small candle ignition source to start the fire. And as you'll see, even though the natural furnishing seems like the fire's growing faster. If you watch here just in a few seconds, the difference between those modern furnishings and those natural legacy furnishings. I think that one of the most important aspects to point out already, here we are 2 minutes and 50 seconds from ignition. Look at our smoke condition on the left compared to the right. How much denser, how much more smoke there is, and how much denser black that smoke is. That's all those toxins, those unburnt particulates from that hydrocarbon that's in that synthetic material that's burning. Again, much deadlier atmosphere, again, higher toxic load, those toxins that firefighters are being exposed to, much higher temperatures, again, that we're being exposed to. And as we see here, where we have a fire on the left that we could extinguish easily with a water can, in that same time frame, we've already run into flashover. So these flashovers are happening much faster, much more violently. You know, the material is so much more flammable than those natural legacy furnishings and legacy fibers that we've had. You know, look here, we're 16 minutes in and we still don't have the same smoke conditions that we had even 3 minutes in with the synthetic materials. You know, when I got into fire service, we didn't have SCBAs for every one of our firefighters. We had a few of them, but, you know, one of the first things I was taught was how to breathe off the nozzle. You know, you could open that nozzle up on a little wider pattern, and you could see why we could do that 30, 40 years ago, because you still had fairly decent conditions with inside that fire. That just isn't possible today because of the different fires that we're facing. So what we need to do is look at better solutions that the water we were using 40 years ago to fight these same types of fires. So even with the modern structure fire, it's still calling for a better solution than just water to help control that fire. So this comes to us from the Firefighter Cancer Support Network, you know, just kind of like what we saw in the video. With modern residential house fires, they have more in common with a hazmat incident than with a legacy house fire because of all that toxic soot and smoke that's being produced from those synthetic materials. In addition to that, we now have the lithium-ion batteries that we're dealing with. You know, they're everywhere. Just think of the modern home between laptops, cell phones, power tools, these mobility devices, the scooters, the hoverboards, the bicycles, maybe RC cars that your kids would have. That there's more and more batteries found in every home, and they're both leading to a fire source, but also contributing to the fire. Video here where we're looking at, you know, not only are the fires worse, it's taking us longer to get there. Departments are being downsized, stations are being closed, response times are increasing, not only due to that, but also the amount of calls that we're responding to. Companies are coming on fills from further and further away.
Assisting the Level Green Fire Department, they dumped over 500 gallons of water on it, and the car kept flaring up. We pulled our trash line off with the F500, and we used 1.5 jugs of the F500 and about 450 gallons of water, and the fire was out. Cooled down enough that the tow truck driver was happy. No flare-ups again once the F500 was in use.
So that came, as you saw from Brian Lee, on a Tesla fire that they were involved with. So let's look at, how big that risk actually is. So if we look at our modern combustibles, we have those synthetic fibers, the complex plastics, glues and adhesives, and even lithium-ion batteries. We combine that with the lightweight construction, truss roofs, gusset plates, the I-joist flooring, oriented strand board that is being used throughout the building. You put those two together and they're giving us very hazardous toxic off gases with high amounts of carbons and hydrocarbons in that smoke. All that together, again, is leading to that quicker flashover, the rapid fire spread, early collapse in a more toxic environment that we're being required to work in. So how can we help mitigate that risk with F500 and with encapsulator technology? So real quick animation here. We're going to just talk about that encapsulator agent, what it is, and how it forms that spherical micelle, the building block of an encapsulator.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the non-polar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So when we think about that micelle, that molecular structure and what it does for us, it gives you some pretty unique features. The first is that encapsulation. So the ability to encapsulate carbon and hydrocarbon, both liquid and vapors, and render those non-flammable, chemically, molecularly separating the fuel from the oxygen. Rapid heat reduction, rapid heat absorption, which leads to a much more tenable, cooler atmosphere, which then gives you long-term stable burn back resistance. But most importantly, this interruption of that free radical chain reaction, which gives us a drastic reduction in the amount of toxins and carcinogenic soot and smoke with improved visibility. So just the next few slides, we're going to do some real quick videos here to go over those three unique features. So again, that first is the encapsulation. Here we're going to be, using fuel. Some of the other videos, when we go on, we'll actually be able to talk with some of the testimonials about encapsulating Class A vapors. But in this instance, we've got some gasoline on the ground using the F500 to encapsulate that fuel, render that fuel as a non-flammable substance. We'll take a torch and ignite the fuel on both ends of that encapsulated gasoline. As you can see, the material in the middle is non-flammable. It can no longer burn because that fuel has been locked inside that spherical micelle. It's been bound up inside the micelle and rendered non-flammable. Here we're going to extinguish the fire completely, and then again, firefighter will use the torch to show that fuel, after extinguishment, after treating with the F500 and the encapsulation that's taking place, is no longer flammable, no longer ignitable. As you can see, he's even walking through the solution. You can't break it down. You can't unencapsulate that. So again, total encapsulation of the fuel, rendering that fuel non-flammable, non-ignitable. So that first unique feature of the product. Second is this rapid heat reduction. So this was some testing that we did in Maumee, Ohio in their burn building. So we were actually pre-mixed at 0.5% with F500, so only 0.5% solution using their burn room. So we have 1,000-degree ceiling temperatures and 1,200-degree temperatures at the base of the fire. You're going to see not a direct attack on the fire. The firefighters just treating the ceiling space above the fire. Shut the nozzle down already. Again, we'll check it now with the thermal imaging camera. So we took ceiling temperatures from 1,000 to 250 degrees and that base of the fire from 1,200 to 400 with a 0.5% solution of F500. So again, very rapid cooling, making that environment much more tenable. So F500 works better with a dispersed pattern than it will with a straight or a smooth bore. That morning fire, that first fire we just saw was with a smooth bore. This now we're going to be using on this fire a combination nozzle. We're still at a 0.5% solution.
See, that lower stuff doesn't look like it's burning. No. That stuff that from this morning.
So we talked earlier about that stable burn back resistance. We built this evening fire on top of what we had previously extinguished in the morning. The material at the base of the fire doesn't want to burn.
9:30 is the top. That's it. I got 9:75 now. It's inside. 9:32 at the top and about 300 at the bottom.
So now we're only 300 at the base, even though we're still around 1,000 at the ceiling.
$470.
So we went from 930 degrees to 113 degrees within that burn room in a matter of 7 or 8 seconds. So we're 77 degrees ambient in the hallway. The next is that encapsulation. To me, again, the free radical interruption, to me, the most important aspect of the agent. So let's think about that modern fire that we saw in the video earlier compared to the legacy furnishings. Pretty similar when we're looking at the smoke coming off of that fire. We have that heavy black smoke, just like we saw in that burn room. But yet how quickly that heavy soot-laden smoke disappears. That's the interruption of the free radical chain reaction, stopping that formation of soot and smoke. So actually the ability to scrub that IDLH atmosphere and improve the conditions for our crews as they're making entry. Proactively scrubbing the smoke, removing the toxins ahead of the nozzle. So when we look at that and how it can affect in a structure fire environment, how we can reduce those risks, I want to draw your attention here to a study that was done by the Laval Fire Department up in the Quebec province of Canada. So the Laval Fire Department partnered with the University of Ottawa. They were looking at the use of encapsulator technology to lower the exposure limit of their firefighters to the toxins, the carcinogenic toxins that are in the smoke. They did this in honor of one of their captains that they lost to job-related cancer. So they dedicated this testing they were doing in his honor to see if they could possibly make the profession a little bit safer. So what they did when they conducted this testing is they had an acquired structure that they did multiple burns in. So the first 2 burns that they did were vent limited. They did one with plain water and one with a 1% solution of F500. So here we have the pictures from fires 1 and 2, those vent limited fires. Here's the observations from the firefighters that were involved in that testing, both interior on the hose crew and the incident commander. As we can see, with the use of F500, they were able to immediately stand following the extinguishment of the fire without feeling any heat because the room had been cooled that quickly. The visibility increased significantly, reducing the amount of smoke that was present. So much better visibility within the room. And then with F500, it was the ability to extinguish secondary fires. When you look at the report, they talk about when they used water on the fire that they had, overhaul to do. There were some fires burning underneath the mattress at the bed. The wood framing around the window was still burning, the window frames. When they used F500, they didn't notice those secondary fires after they shut the nozzle down. From the incident commander's point of view, again, comparing fires 1 and 2, there's no doubt from an external point of view that fire 2 was brought under control much more quickly, and there was much less residual smoke after the F500 was used. Now, in addition to the observations, what else they were doing is in between each evolution, the firefighters were donning brand new protective hoods. After each evolution, those hoods were taken off, they were bagged, and they were given to the University of Ottawa that performed testing on those hoods. So this was fires 3 and 4. These were actually not vent limited. They were a vented fire. As you can see, they took some of the plywood off, so they had a vent opening for the fire for these 2 fires. So again, the observations from the hose line crew and the incident commander, after the initial application of F500, flames on the floor disappeared in a half a second. So we talk about that encapsulation ability of the agent to encapsulate flammable vapors. Well, what's burning in a Class A environment? That material is breaking down through pyrolysis, off-gassing flammable combustible vapors. The agent instantaneously encapsulating those vapors takes the fuel source away, which gives you that almost instantaneous removal of the fuel that puts the fire out, takes the flames away. The decrease in smoke generation was striking, most importantly because they said that second fire with F500 was a more violent fire than the one they used to extinguish with water. And again, there was also considerably less smoke within the room after applying F500. Again, we see the same thing as we saw with fires 1 and 2 from the incident commander, that the fire was brought under control much more quickly and that there was much less residual smoke after the fire on the outside of the structure. So when we talk about what those firefighters saw and what their observations were, those can be subjective. Somebody else's observations may have been a little bit different. Maybe they didn't think it was as drastic. This, though, is fact. We can't argue with what the results of the testing were from the University of Ottawa. So when they looked at those hoods and they compared the polyaromatic hydrocarbons that were trapped in that material of the hoods that they tested, they saw drastic reductions when F500 was used. So much less of those toxins trapped within that hood material. As we can see, a 71% reduction, an 83% reduction, a 60% reduction, 63, 83, 89, 90. We come down here, we went from above the level of detection to below the level of detection. Same here. The other materials, Who knows? It was both were below the level of detection, but there easily could have been a decrease there. And when we look at some of these highest reductions up here, some of these materials, you know, I'm sure I'm going to butcher the names, but the naphthalene is used in plastics, synthetics, fibers, and dyes. The next one here is used in plastics, polymers, and electronics. The fluorine's used in plastic and dyes. The anthracenes, plastic and synthetic fibers. The fluoroethane, it's a byproduct of burning wood, you know, that we have in every structure. The pyrenes are used in plastics and LEDs. We're finding all of this material in a modern structure fire. This is what we're facing from the plastics and the synthetics that are now inside those structures. So this was the conclusion from the committee. So this was 30 firefighters that were in that group. The committee they formed to evaluate and assess the encapsulator agent. So the committee's confident. This was a unanimous decision by the committee. The committee is confident that the encapsulating agent reduces the firefighters' exposure to carcinogenic contaminants. Furthermore, its use is also effective for Class B, C, and D fires, while water should not be used on those categories of fires. For those reasons, they are moving forward with the use of an encapsulating agent to prevent cancer in the Laval firefighters. So this was a study by firefighters for firefighters. So again, great information. Let's look at some real world uses with F500. So this is a structure fire in Omaha, Nebraska. Another F500 department user. They are pre-mixed in their booster tank at 1%. So one of the things we'll look at here, you'll see in a second, when the firefighter is going to look back to look at the engine, he's asking for water. I'll stop the video real quick here to point something out to the group. Yeah, as you see, we have a pretty well involved fire on the porch.
I got water.
Truck 63 is splitting. Truck 63.
You got water?
Notice the firefighter on top of the pumper. He's trying to position the deck gun. They, you know, they're getting ready in case this gets away from them in a hurry based on what they're seeing. Sorry about that, from the truck.
I got water.
Understood. Truck 63 is splitting. Truck 63.
You got water? What's up?
Come in on site.
I'll point out too, this is a rookie firefighter on the nozzle. So as we see from that single hand line, a pretty rapid knockdown on the fire.
Hey, back up. Yes, sir.
So they had complete knockdown in 1 minute and 44 seconds. So if they were using 150 gallon per minute nozzle, they had knockdown with less than 300 gallons of a 1% solution. What I want you to do now is watch as he's continuing to hit some hot spots here on the porch. Watch how quickly the environment improves. Watch how quickly the smoke disappears and dissipates here in the next few seconds. So again, rapid cooling, encapsulation, removing that soot and toxins. Watch as the firefighter is going to go up and get ready to make entry through the front door. Look how clear conditions are on the porch. You can actually see the front door already. There was no spread of the fire into the structure. They held it to the front porch because of the rapid knockdown. The fire was under control in 3 minutes and 8 seconds. They started picking up 15 minutes after they arrived on scene. So we're talking about on-scene time for a structure fire. If we can be back in service sooner. Remember, we talked about with the video from New York, response times are increasing because we're busier, we're running more calls. If we can get back in service faster, available for the next call, hopefully we can decrease those run times. Less time on scene means less wear and tear on the firefighters. Again, helping out with that safety benefit. Real cool. I actually just myself discovered this video a little while ago. Apparently we've had it for a while. I just wasn't aware of it. So this was some testing, some training they were doing in Modesto, California at the Fire Academy. So this is a propane fired fueled prop. You're going to notice that the fire is not completely extinguished with F500. That's because, again, they're using a 1% solution on this fire. We need 3% solution for that total hydrocarbon encapsulation to put that fire out. What I want you to watch for, because it's propane and we don't really have the smoke from burning Class A materials, they've already pre-treated the room. So what should we have when you have a superheated room and you apply water to it? You're going to make steam. Watch when they apply the 1% solution of F500. You're going to see visibility never changes. There is no steam being generated with the F500 being applied onto the fire. So again, opens up with that dispersed pattern. Again, no steam being created. So we're worried about if we have an underventilated fire like they had in Laval, when you open up that nozzle, particularly like this on a wider pattern, we're going to drive all that soup down on the firefighters, all that superheated steam that's created. We are not creating that superheated steam. So again, that safety benefit, making that environment cooler, not only for us, but potentially for any trapped occupant that may be in there. This is some other testing that was done. This is in Cornelia, Georgia. So we're doing burns inside their Class A burn building, but here we actually are burning pallets. So 1% F500 solution, about a 7-second knockdown on the fire. Shut the nozzle down. Again, you'll see how quickly conditions improve inside that burn room with only that very short application. So here we're looking at temperatures in the room. Again, we're down around 150, 130 degrees in the room. More importantly, we came in with a 4-gas meter 2.5 minutes after extinguishment. So his comment was, that's impressive. We're at 13 parts per million, 2.5 minutes, 13 parts per million of CO, 2.5 minutes after extinguishment of the fire. So again, a drastic improvement in that IDLH atmosphere, drastic improvement in your visibility, in your conditions inside that structure fire type environment. So how do we get F500 in the water? Again, you can put it in your water can. So a 10 ounces of F500 concentrate will give you a 3% solution inside of your 2.5 gallon water can, drastically improving the knockdown capability of that extinguisher. You can batch mix right in your booster tank for whatever you need. You can use a manual eductor and nozzle, you know, that matched nozzle and eductor, or if you have an onboard proportioning system, you can use that onboard proportioner to proportion your F500 into the stream. Pretty much any way you can think to put F500 into that stream, it will work for you. Some of the approvals and listings that we have with F500. So first and foremost, it's a UL listed Class A and Class B fire suppressant agent. It's also listed on the EPA's National Contingency Plan as a surface washing agent. So it can be used to treat hydrocarbons on the ground, things like gasolines, oils, and diesels. It's listed with the Mine Safety and Health Administration as a firefighting agent for mine fires. And the most recently approval is we are now listed through the FAA as a complementary fire suppressant agent for aircraft rescue and firefighting. Just some of the departments all around the country. Canada, don't have any of the internationals on here aside from Canada, but just a small sampling of some of the departments that have already switched to encapsulator agents to not only make their departments safer, but gives them a more versatile product to handle a multitude of fires. That brings me to the end of my presentation. I want to thank you for your time, but I'll leave you, before we open it up with questions, from this drawing from Paul Combs, you know, and I think it speaks to the use of F500. We know we are very resistant in the fire service to change, but, you know, are we willing to change to do it better, faster, and safer, or are we going to be stuck with the way we always did it? And with that, I will open it up to questions. So we have a couple questions here. You know, how does F500 react with heavier, longer hydrocarbon chains and asphalt? Will it degrade it? No, we actually see the opposite happening with the asphalt, particularly when you're treating a hydrocarbon spill. It actually, that surface washing agent, it solubilizes the hydrocarbon that's on there. For quite a few years, NASCAR was actually using F500 to treat the racetrack when they had a spill on the track, because it would clean the track so rapidly that they could get back to racing faster. So it actually doesn't degrade that asphalt. It actually helps remove that oil, that gasoline that seems to be even more detrimental to the asphalt, and eliminates a lot of that. Other question here, has there been any testing or analysis done with the use of F500 with an automatic sprinkler system covering high-powered storage? In particular, do you have concerns with racking inhibiting the efficiency of the encapsulation of F500? F500 is used extensively in fixed system applications like sprinklers. We have it on everything from, particularly what you're talking about here is the rack storage. Embraer down in South America actually protects their warehouse with that rack storage with F500. We work with several of the auto manufacturers around EV with rack storage of the batteries as they're being charged. Excuse me. So it's still, it's used on both open deluge system, things like transformers, under turbine lube oil. It's used in the power industry on coal conveyors, above the headspace in some of the dust crusher rooms, in dust collectors, various applications where F500's used in fixed systems. The NASCAR use for spill mitigation, the last I knew, Charlotte Motor Speedway was still using F500. I'm not positive on that. I have several other smaller racetracks that are using F500. In addition to HCT is also members of the Council of International Motorsports Sciences. So we actually work with those guys to help bring the technology to the forefront there in the racing industry for its benefits, not only on spill encapsulation, but also, you know, what's happening now with batteries and some of the issues with Class D metals at the tracks.
Yeah, Ron, you have some question in the chat, but you can finish to answer in the question and answer.
Yeah, so we have a question here. Has there been any testing with EV vehicles with the battery in a place similar to like a garage type structure? Yes, there was recently this past year testing done over in Spain. It was a certification testing for an F500 suppression system for parking garages. And that system has been approved. It is being used now in Europe for EV fire protection in a garage, in a parking garage. Is there another question? Has there been any definitive testing or analysis to show that F500 is safe and does not have any long-term or severe effects on aquatic life? Yes. So the F500 has been tested extensively. We have both aquatic testing, terrestrial testing, mammalian testing, skin sensitizing, eye irritation. When it comes to the aquatic effects, particularly, the F500 can have an immediate effect on aquatic life, not because it is a hazardous or a toxic substance. It's because it is a very strong surfactant, and it can coat the gills of the fish, enabling them to breathe. As it is dispersed through the water column and the F500 is diluted by the water, it has no intermediate or no long-term or permanent aquatic impact. Our BOD, COD, which is the biological oxygen demand and the chemical oxygen demand, is very low. So we aren't removing the oxygen out of the water, which will kill fish long-term. It's just that potential immediate aquatic impact where it gets into the stream. So question here, any airports that are using F500? Yes, several. We have John Glenn in Columbus, Ohio has F500. The Rochester International Airport in Rochester, New York is F500. Bradley International in Connecticut has F500. And the most recent is Newark has recently purchased F500. So the airports are that's actually a goal for HCT this year. That's one of our focus markets that we're really looking now that we're in that AC 150 circular. We're really looking to push into that aircraft airport market. But yes, there are already several airports that are using F500. Question here. Last year, you showed a video of the testing in a garage showing the effects on the adjoining car. Can we get a copy of that video? I will check on that. I know we have some of it. We've been asked, I believe, not to share it until the official certification report is out. But I will check with my bosses and see if we have the ability to get that video out, which I believe we can. I just need to double check on that. I'm not 100% positive. Hernan, do you know?
No, we have the video that we can share with them, the test in Spain.
Okay.
But we don't have the final report yet.
Yes, yeah, I wasn't sure if we were permitted to share that video yet. I knew we had it to show, but I didn't know if we were allowed to share it. So what third-party certificates issued for F500 in relation to hazardous health conditions? So a lot of the testing, the majority of that health testing that was done on F500 was done in Europe. A lot of it was done by the Hygiene Institute. The reason for that is the European standard, I'll say, is much stricter than the US standard. So in the United States, chemical usage, you're allowed to use a chemical until it's determined to be hazardous, and then its use is restricted, kind of like what we're now dealing with PFAS. In Europe, they've adopted what's called the REACH standard. As part of that REACH standard, you have to prove that your chemical product is safe to use before it's allowed to be used. So a lot of that testing needed to be performed in order for us to meet that REACH standard over in Europe. So that's why we have that that testing is mainly done over there in Europe. Do you know any international clients, fire brigades, or airports? Yes, Turkey has, as far as airports go, Turkey, the airports, all the airports in Turkey are protected now with F500, including quite a few in China. I believe there's at least a dozen airports in China that are protected with F500 in their ARF trucks. I'm sure Hernan would be much more versed as far as South American departments or brigades that are using F500 than I am. We could also, if you want, get specifics from our European subsidiary as far as departments in Europe that are using F500.
Yeah, there are some fire brigades on mining in Chile. There are some power companies in Bolivia and different companies in Brazil that they are using the fire brigades. In this moment, maybe 3 or 5 days ago, we have a tire fire in Panama that the propagation go to a landfill, and in this moment they can stop the propagation and they can extinguish the fire with this encapsulator technology.
Yeah, as far as refinery clients, Hernan said there may be a few in South America that refineries with F500, it can be used in conjunction with foam for some of those large above ground storage tanks, but that's actually not a sweet spot application for F500. So it's that's a market that we don't push as much into, shall I say. We have a follow-up question here on the aquatic impact, if the documentation from those studies are available. They absolutely are. If you want to follow up with an email to info@hct-world.com with that request, we can get you copies of all of those test reports. Question here, could the states ever see a UL rating on the 9-liter extinguisher in regards to state and city requirements for extinguishers in business? Yes, we are actively pursuing that. We hope to have that done this year as far as a UL listing for that extinguisher. The international certifications, I again will have to pass that one off to my VP there, who does more of the international sales that I do as far as international certifications.
Yeah, we have a certification from Europe. We have a certification from Canada. We have a certification from Brazil, Italy, SOLAS. Yes, Alexander, we have CA on the product. CI, sorry, in the product. And we have an Australian certification too.
Nigeria, I believe, as well.
Nigeria is other certification that we have. If you can
Jake, for the
answer,
rating on the extinguisher, when we get it, it's more than likely going to be a Class A because the bulk of the sales for our extinguishers are on batteries, and there is no listing. So it's probably going to be a 3A listing on the extinguisher.
we have other question here in the chat, Ron. That's Sandy Corda asks, what made your encapsulation product different or better than other on the market, such as fire-free, that is cold fire?
So those other products, to my knowledge, can't meet the NFPA 18A77 spherical micelle stability test protocol, which F500 meets that test protocol. So unless you can meet that test protocol, you're not truly an encapsulating agent. That test protocol is testing that your agent forms and maintains spherical micelles. And that micelle is what makes an encapsulating agent do everything that it does. So if you aren't forming spherical micelles, you're not a true micellular encapsulating agent.
Wonderful. Tom Logrande said, my understanding is that this product needs to be aerosolized for best performance. If that is correct, how does this product work with a smoothbore nozzles compared to fog nozzles, such as the Task 4 tip?
So you are correct. The agent can be used in a smoothbore nozzle. It works better in a combination nozzle. So the smaller, the finer droplet you can get, the more encapsulation and the more cooling that happens. You can use it in a smoothbore, but just as we saw with the testing with Maumi, you achieve greater cooling with a combination nozzle and greater encapsulation than you do with a smoothbore.
Okay. We have the last question from Karina Formengo. Is two questions I put here in the chat, the run of team. She said, had a hard time hearing, is a powder or liquid in concentrate form?
It's a liquid in concentrate form.
Okay. Does it stay mixed long-term if add to water extinguisher? And what is the freezing point?
So in water, it's a 5-year in solution that the agent stays mixed with water for 5 years in solution. The freezing point of the concentrate is 27 degrees. So recommended storage is 35 to 125.
And the last question from Karina is, what NFPA covers A500 agent?
So it's NFPA 18A, water additives for fire control and vapor mitigation.
Okay, Ron, we are on time. If somebody wants to put in the question and answer the last question. If not, I want to say thank you for the people that connect on our YouTube channel. You can see this recording in our YouTube channel, and you can enter in our website to try to receive all the information and all the document that Ron commented today in this presentation. Later this week, we will send you an email with all the information and we'll share this PowerPoint. Okay, we have the last question from Jay Kennedy. When you answer this question, Ron, you can say goodbye to everybody.
Okay.
And say thank you that the people can, they assist here all this hour.
So what's the last question here, Ron? I don't see it.
You see, I heard there was a formula for adding antifreeze to extinguisher. Is that true? Yes.
Yeah, so we have done testing with F500, not into concentrate, but into solution. You can use propylene glycol, virgin propylene, or food grade propylene glycol. We have a mixing chart depending on the temperatures that you would expect, the low temperatures you could expect to anticipate facing. Up to a 50-50 mixture of plain water with F500. So if you had a 2.5 gallon water can, 1.25 gallons of plain water, 1.25 gallons of propylene glycol gives you freeze protection to -30 and burst protection to -60.
Okay, and the last question, Ron, here in the chat is, what are hazardous effects of using A500 on the ecosystem?
The only hazardous effect that we know of or that's been shown is potentially that immediate aquatic impact. Again, there's been seed germination testing. There's been mammalian toxicity. There's been terrestrial toxicity. None of those, all of those show that F500 rapidly biodegrades in the soil, and there is no long-term or immediate impact aside from that initial aquatic impact that we found.
Okay, thank you, Ron. And here in the chat, we put our website and we put the address where you can enter and see all the webinars that we will have for all 2024. Please, we invite you to participate in the next webinar, and we want to say thank you to participate in this webinar. Ron, you can say goodbye to everybody.
Thank you, everybody, again. Thank you for your time. I really appreciate it. I know your time's valuable. Thank you for sharing a little bit with us today. Have a great evening, morning, afternoon, depending on where you're joining us from.
Very good. Bye, everybody.